We're going to continue the calculation on the volumetric analysis. Yes. The titration we did yesterday, we're going to use the result to solve the following questions. Now, we are going to read the question one after the other, analyze the question, and then solve them. The question said A is a solution containing 28 gram per dm cube of tetrodosi of a 6 acid. G is a solution of x gram per dm cube of sodium hydroxide using your table. The result you got yesterday. Using that table, calculate the following. I, the volume of the acid used. II, concentration of A, which is the acid, in mole per dm cube. Then 3, concentration of B, that's the base, in mole per dm cube. Then 4, mass of salt formed when 500 centimeter cube of B, that's the base, is completely neutralized. Then the relative molecular mass of sodium is 23, that of oxygen is 16, that of hydrogen is 1, and that of sulfur is 32. Now, we are going to solve this question one after the other. Solution. A is a solution containing 28 gram per dm cube of sodium hydroxide. Now, before we go into this, let us make our table and then write out our results. In our table we have titration, and then we have the direct reading, and then we have the first reading. Just like I said, I'm going to make use of the rough. We have the second reading, then we have the third reading. So because I'm using the rough, I'm assuming there was no rough. Do you understand it? Do you understand what I said?
Yes, sir.
So the first, here we have the initial reading. Sorry, we have the final reading here. Final in centimeter cube. Please, you must put the unit of what you are reading there. Put the unit here. If you don't put it here, it means you are going to put it at the back of each number inside the column. But to make the work beautiful, you have to put it here. Then the next one is the initial reading. Initial, which is in centimeter cube. And then we have the titer value, or which is the volume of acid used. Either you call it the titer value, or you call it the volume of acid used. Now, in the first reading, our initial was 0.00. Like I said before now, you must record in 2 decimal places. Don't forget it. It must be in 2 decimal places. The initial volume of the acid, 0.00. Then the final volume, check your notes. What's the final volume? 11.50. Now, since we have 11.50, to get the volume of acid used is going to be the final minus initial. So 11.50 minus 0.00, what's the answer? 11.50. So this final here will become our initial here. You can also fill back, like some of you did, to fill back the acid to the brim, to fill back the acid, the bread with the acid to 0, back to 0. So you record 0 here. So here, from here we'll write 11.0 as my initial. The final here was what? 22.00. So the volume of acid used is what now? 22.00 minus 11.5. 10.50. Then here our 33.00. 33.30. Alright, 33.30 minus 22.00. 11.30. Right. So the question here said, this is our table. And the question said, using the table, calculate the volume of the acid used. The volume of acid used is going to be our average titer value, or the average value of these three values. So we write average titer value. Average titer value is equals to 11.50 plus 10.50 plus 11.30 divide by 3, just like you calculate your average or your mean. So somebody use your calculator. 11.50 plus 10.50 plus 11.30 will give us what? Use your calculator. Divide by 3. Whatever you get, divide it by 3. 11.10. Okay. We have 11.10 centimeter cube. Always put the unit. Don't forget. Now, the second question said, calculate the concentration of A in mole per dm cube. Concentration of A in mole per dm cube. Now, there are two concentrations we have under this. One is concentration in gram per dm cube. Another one is concentration in mole per dm cube. Now, concentration in mole per dm cube. Another word for this concentration in mole per dm cube is also solubility. When you hear the word solubility, concentration, they are talking the same thing. They are saying the same thing. So, concentration, I'm going to use conc as the short form, or solubility in mole per dm cube. In mole per dm cube. In mole per dm cube is given as mass concentration. It's given as mass concentration over mass concentration over molar mass. Over molar mass. The formula for concentration in mole per dm cube, or solubility in mole per dm cube, is equals to mass concentration over molar mass. But sometimes, if the mass concentration is not given to you, you have to find the mass concentration. So mass concentration, the formula for mass concentration becomes mass concentration is equals to the reacting mass over volume in dm cube. The volume must be in dm cube. So if the volume is not given in dm cube, you must convert to dm cube. So it's going to be reacting mass over volume in dm cube. If the volume is not given in dm cube, you must convert to dm cube. So let's solve this one. The concentration of A in mole per dm cube. A is 28 gram per dm cube, which means what they gave us here is the mass concentration of A. Mass concentration of A. But it will be very important for us to first of all do the reaction, but even if we don't, we can still get the concentration of this without that. Okay, let's first get the concentration of acid. The acid here, the molar mass of the acid. Can somebody help me to calculate the molar mass of the acid? Continue here. The molar mass of the acid, somebody help me. H2SO4. What's the molar mass? Here we have hydrogen. Hydrogen is 1 times 2 becomes what? 2 plus sulfur is 32 plus oxygen is 16 times 4. Everything is what? 98 gram. Beautiful. 98. Now, the concentration of A in mole per dm cube becomes the mass concentration over the molar mass. The mass concentration has been given, so we have the concentration in mole per dm cube is equals to the mass concentration, which is 28 gram per dm cube, all over the molar mass, which is 98 gram. Now somebody use your calculator to finish this work. 28 gram over 98 gram. 0.286 mole per dm cube. 0.286 mole per dm cube. This becomes the concentration of the acid. This becomes the concentration of the acid. Now, the second question said concentration of concentration of B is SO4 plus the base, which is sodium hydroxide. When they react together, they will produce salt and water. Neutralization reaction produces salt and water. So the salt that is produced here is sodium tetraoxosulfate 6 aqueous, and this is aqueous solution, and this is aqueous solution plus water. Is the equation balanced? Is the equation balanced? Now I want to balance the equation. How many number of sodium is here? How many number is here? So to balance the number of sodium, we put 2 here. Now sodium is balanced. Hydrogen, is it balanced? Hydrogen is 2 here. Hydrogen is 2 here, making it 4. And hydrogen is only 2 here. So if I put 2 here, hydrogen is balanced. Am I correct? Yes. Now tetraoxosulfate 6 is 1 here and is 1 here. Then oxygen is 2 here and oxygen is 2 here. Am I correct? Yes. So it's balanced now. Am I correct? Yes. Alright, so the equation of the ratio of reaction is 1 is to 2 is to what? 1 is to 2. That's the ratio of reaction, which means the ratio of this reaction is that the volume of acid, if the volume of acid is 1, then the volume of base will be 2 for complete neutralization to take place. Now, since we know this, our formula says that Ca, which is the concentration of the acid, times Va, which is the volume of the acid, all over Cb, concentration of base, times the volume of base, which is Vb, equals to the ratio of reaction of A over the ratio of reaction of B, or you call it molar ratio, mole ratio. Now, since we know this concentration of acid, concentration of base, volume of acid, volume of base, and the ratio of reaction between A and B is this, we are going to substitute our value. What we are looking for is the concentration of B in mole per dm cube. And what we have here is the concentration of A in mole per dm cube. Who can tell me the volume of acid here? What is the volume of acid here? What is the volume of acid Va? What is the volume of acid? You see that value you calculated as your titer value, 11.10, that is the volume of acid. Then who can tell me the volume of base here? No. The volume of base is the volume of your pipette. That pipette we are using to solve. The volume of that pipette is the volume of your base. Is what? 25.00. Alright, so let's go. Ca is equals to 0.286 mole per dm cube. And then Cb is unknown. That's what we are looking for. Va is equals to our titer value, which is what? 11.10 centimeter cube, and then Vb is the volume of our pipette, and that is equals to 25.00 centimeter cube. Alright, so the ratio of reaction for Na is equals to 1 and Nb is equals to 2. So we substitute our values here. We are going to have Ca 0.286 times Va 11.10 centimeter cube all over Cb is what we are looking for, is unknown. Vb is 25.00 centimeter cube is equals to Na is 1 all over N2, Nb which is 2. So by cross multiplication, we have that 0.286 times 11.10 times 2 is equals to 25.00 times 1, then times Cb. So making Cb the subject of formula, we are going to have that Cb is equals to 0.286 times 11.10 times 2 divided by 25.00 times 1. Somebody use your calculator to finish that word. The final answer 0. Alright, so we have here 0.25 mole per dm cube. So our Cb is equals to 0.25 mole per dm cube. Always put the unit. Write down. The fourth question, which is the last one, said the mass of salt formed when 500 centimeter cube of the base is completely neutralized. The mass of salt formed when 500 centimeter cube of the base is completely neutralized. Please, I want you to pay attention here. This one is not as straight as these other ones. Before this thing can happen, first you must know that in every reaction that takes place between acid and base, the water does not go into reaction. What goes into reaction is actually the mole of the acid and the mole of the base. Before you will be able to calculate this, you must first of all get the mole, which is the amount of the substance reacting. From the amount of the substance reacting, you can now find the mass that is reacting there. So let's move on. Let me clean this side. We are going to find the mole, the amount of B at work here first. The mole that is working here. Now we know that number of moles or amount is equals to reacting mass over molar mass. In this case, we are looking for reacting mass and we don't know the number of mole, but we know the molar mass. Okay, we can keep this formula and check another formula. If we come to the second formula that says that molar concentration is equals to mass concentration over molar mass, and mass concentration is equals to reacting mass concentration. So if I say the concentration in mole per dm cube, which is conc in mole per dm cube, is equals to mass concentration, and mass concentration is reacting mass all over volume, then over molar mass. Do you understand this formula? Do you understand what I did there? Yes. Alright. Ask. You don't. I said that concentration in mole per dm cube is equals to mass concentration over molar mass. But mass concentration on its own is equals to reacting mass over volume. So instead of me to put mass concentration here, I just put reacting mass over volume, then over molar mass. Do you understand it? Right. So if we have this, And we have the mass concentration of B. The mass concentration of B, okay? We don't know the mass concentration of B. We don't know the mass concentration of B, but we know the volume given to us. We know the volume. We know the molar mass. So the volume given to us is, we know the concept. Okay, this is what we are looking for. We have this. We have the volume. We have the molar mass. We are looking for the reactive mass because the question said mass of salt formed when this 500 centimeter cube of B is completely neutralized. So what I'm going to do now is to convert this to dm cube because everything we are doing in volumetric analysis is in dm cube. So if 1 dm cube is equals to 1000 centimeter cube, then how many dm cube will give us 500 centimeter cube? Somebody solve. What is the value in dm cube now? What is the value of S in dm cube? Cross multiply and get the answer. If 0.5, it means S is equal to 0.5 dm cube. So the volume here is 0.5 dm cube. So what we are going to do now is the concentration is 0.25 and then the reacting mass is what we are looking for. The volume is this and the molar mass. We know the somebody calculate the molar mass of sodium hydroxide. Sodium is 23, then oxygen is 16, hydrogen is 1. 23 plus 16 plus 1, you get the answer. Somebody calculate it, write it somewhere. 40. Alright, molar mass of sodium hydroxide. Is equals to 40 grams. So if we substitute these values into this equation, we are going to have, if we put the values into the equation, we are going to have the reacting mass, which is what we are looking for. Okay, let me make the reacting mass the subject of formula. Concentration is equals to 0.25. 0.25 is equals to the reacting mass all over the molar mass, the volume, which is 0.5, over the molar mass, which is 40. So if I have the reacting mass over the volume, will give me 0.5 divided by 40. Somebody use your calculator.
And 0.0125.
The reaction mass over 0.0 what? 125, right? 0.0125. 0125. Alright, the reacting mass number of moles. Sorry. This has to be the reacting mass over times 1 over 40. Times 1 over 40. So if I have 0.5 times this, will give me 0.5 times 40 will give me 20. So I will have reacting mass 0.25 is equals to reacting mass all over 20. So if I cross multiply, the reacting mass is going to be 20 times 0.25 is equals to what? 5. 0.5. 5, just 5 gram. Do we understand this?